Okay, so this video is going to be about the properties of the special parallelograms. Remember, there's three types of special parallelograms. You have the square, all of its sides are the same, rectangle, its opposite sides are the same, and then you have a parallelogram. Not parallelogram, a rhombus. Okay, I'm sorry. Square, rectangle, rhombus. Now, square, um, it has some special properties that a parallelogram does not. One is that the area is still base times height, but the height you don't have to find from the middle anymore, so it's base times height, or it's just the side and you square it. It means the same thing. Diagonals, meaning these little diagonals in here, they do two things. They'll not only bisect each other, meaning that they cut each other in half, but they also bisect the angles, meaning cut in half. Bisect equals cut in half. And since all squares have, and then all squares, all angles and squares are 90 degrees. Okay. Rectangles the same way. Area is base times height. The diagonals just bisect each other. They do not bisect the angles. And all angles and rectangles are 90 degrees. And finally, rhombus. Rhombus is a little bit different. You can find the area in two ways. Area equals either base times height, or area equals 1/2 times diagonal 1 times diagonal 2. There will be times where I'll give you this, and there'll be times I'll give you this, and you should be able to find the area from both ways. And then diagonals bisect each other and bisect each angle. Okay? Those and all sides are equal. Those are actually all the different, those are the three special types. Now, squares and rectangles, I don't see you guys having too much problems on. The one I'm going to really focus on is rhombi, because of this. I'm going to tell you something like, it's easier with squares and rectangles, knowing that all the angles are 90 degrees, but in a rhombus, you don't know that. So, I'm going to start giving you something like this. I'm going to give you like this angle right here is, let's say, 35 degrees. I'm going to tell you to find the length of each angle. So I'm going to tell you to find A, B, C, and D. So I can tell you to find the length of each angle. So if I give you essentially the first one, we know that this diagonal cuts this angle in half. I gave you half the angle, which is 35. So that means the other half has to be the same. So let's say if this was 35, this would also be 35. That would mean B total is 70 degrees. Okay. Now, how you're going to be able to tell this is a rhombus is I'm going to do this. I'm going to show congruent markings on all of them. Alright. Congruent markings show that this is a rhombus and not just a regular parallelogram. And that's going to help you out. With a square, you'll have the four sides are marked like that too, except for it'll be up straight, and I'll probably put a 90-degree angle in there to show that it's a square. A rectangle is just going to be given, it's going to show congruent markings but with opposite sides, and it's going to have a right angle. And that's how you're going to be able to tell the difference between these all. This one, you're just going to have four congruent markings. So, you figured out that B was 70 degrees. That means D, since it's a parallelogram, still, it's a special type, it's still a parallelogram, is also going to be 70 degrees. To figure out A, it's still a parallelogram, same side angles, add up to 180, so if you take 180 minus 70, you get 110 as your answer. So that means A equals 110 degrees, and C equals 110 degrees. Another thing is that I'm probably going to do this more often than with normal base times height, is I'm going to tell you guys to find the area by using diagonals. So let's say I gave you this diagonal was 5 and this diagonal was 12. Or not the whole diagonal, but that half a diagonal. Once again, we know that diagonals in parallelogram bisect each other, means they cut them each other in half. So you know that this is 5, you know this side also has to be 5. And if you know this side is 12, you know this other side also has to be 12. So in total, this diagonal, the first diagonal, should add up to be 10. And in total, this second diagonal should add up to be 24. And as I said before, area for a rhombus can either be found by base times height or 1/2 diagonal 1 times diagonal 2. So if you guys knew the Pythagorean theorem, you could actually figure this out, but you guys don't know that yet, so we will not discuss it. Anyway, so I'm going to tell you to find this by taking 1/2 diagonal 1 times diagonal 2, meaning we're going to take 1/2 times 10 times 24. And if I put that in my calculator, what I'll end up with is that the area is 120. Those are all the special types of parallelograms. I'm going to be using those. You gotta write these down, know how to do them, and everything like that. But I'll be using those to help you guys on these worksheets. And this is the last of this unit. Alright, thank you.